Okay, hold on to your hats. This is 14 pretty difficult log questions, depending on what level you're at. Um, you might hear the occasional flicking of paper, which you will never normally hear during my my video tutorials. I normally do all the maths just myself, just out of my own head, but these are difficult enough, and I want to keep up a good pace so that you can pause the video if you need more time. But if you don't need more time, you're not being held back by me. Um, so I've got some bits of paper to make sure I don't make any mistakes. So I'm going fast. Right. Okay. I'm just going to get going. Pause the video if you need to, obviously. I'm going to do P to both sides. I will speed up, by the way. I'm just a bit slow to start off with. Right. That cancels, which means that 1 over 27 equals p to the minus 3, which means that 1 over 27 equals 1 over p cubed. Oh look, so that means that p equals 3 by inspection, because that's the only way both sides can be the same, and obviously it's cubed, which means it's going to be positive because it retains its sign when it's being cubed. I'm going to remember to pause the video if you need more time. I'm going to do both sides to the power 5. They cancel because they're inverse functions, so q is simply 5 to the 1 over 125. That's the final answer. R equals 0, just because it is, because you can just work it out. Okay. I'm just going to start writing and see how fast I can do this. By the way, if you're feeling like, oh, I can kind of do this-ish, then if you don't want to have to sit around watching me do it, you could always just try and do it at the same time as me, because you're still getting the learning experience and you don't have to sit and watch me. Right, I've just saved some time. I've slung that up there, and then I'm going to save some more time. I wouldn't normally do this. I'm just saving time on this video. So then I do the power 3 to both sides, which means that I end up with 7 plus 7x over x plus 1 squared equals 3 squared, which is 9. So then I can multiply both sides by x plus 1 squared, so I end up with 7 plus 7x equals 9 times x plus 1 times x plus 1, which means if I kind of multiply all that out and rearrange it, I get 9x squared plus 11x plus 2 equals 0, which means I can factorize it, and I end up with 9x plus 2x plus 1, which means that x equals minus 2 over 9. Now it can't be the other value because the other one wasn't greater than minus 1. Let's do the next one. Okay, by inspection, the inside of the logs have to be the same because that's the only thing that's different. So x squared equals 64, so x equals plus or minus 8. Remember to keep pausing the video at the start if you need to, so you can have a go in your own time. Here's a funny one, this. Log to base 2 of x equals the square root of log to base 2 of 64, because notice that square was like just the whole thing, and actually log to base 2 of 64, well, that's just 6, so that'd be log to base 2 of x equals the square root of 6. So I can do 2 to the power of both sides. It cancels here because it's an inverse, so x equals 2 to the root 6. Let's do the next question. Well, I'm going to bring this over the other side, so it'll be minus. So it'll be log to base 7 of 1 minus 6x minus 2. Actually, I'm going to do two things at the same time. There we go. And then I can combine those. So that'd be log to base 7 of 1 minus 6x divided by x squared equals 1. And then I can do both sides to the power 7. They cancel because they're inverse functions. So 1 minus 6x divided by x squared equals 7, which means that I'm going to multiply by x squared. 1 minus 6x equals 7x squared. and then I can just rearrange that to be 7x squared plus 6x minus 1 equals 0, which means 7x plus 1 times x, minus 1 times x plus 1 equals 0. This one isn't possible because x has to be greater than 0. So that means that x equals 1/7. That's the answer. There we go. Let's try the next one. Well, we can just do log to base 11 of both sides. Oh look, they're inverse functions and they cancel, so x equals log to base 11 of 3. There we go. Let's try the next one. If you've not seen this, good luck guessing. The trick is to notice that there's 7x squared. Oh, so that's just basically, it's just a quadratic. I've got to make, I'll do minus 3 and minus 2, that works. And then that means that 7 to the x equals 2, or 7 to the x equals 3, which means I can do log to base 7 of both sides, which gives me x equals log to base 7 of 2, or x equals log to base 7 of 3. So just to clarify, I'll just do it in a different colour, because sometimes I'm in danger of just going a bit too fast. I've done log to base 7 of both sides. I've observed their inverse functions, which is how I get that final answer. Let's look at the next question. We could take this first one here, and we could say, well, I can therefore say that log to base 2 of x, y equals 5. And if I do 2 to the power of both sides, these cancel because they're inverse functions. And that tells me that xy equals 2 to the power 5, which is 2, 4, 8, 16, 32. So that's 32. So I've now got two equations here which I could combine. So let's combine it as, let's substitute in 4x for y. So that means x times 4x equals 32, which means that x squared equals 8, which means that x equals square root of 8, and it said in surd form, so I'm going to write equals 2 root 2, so I just kind of like doing that. And then that means that y is, well, it's just 4 times x, so that'll be 2 times 4 makes 8, so that'll be 8 root 2. There we go. Let's look at the next question. Express y in terms of x. So this isn't really a solve, this is more of a rearrange. So basically we need y on its own, which means I've got to get rid of the 2 and the minus 1 and the log from around it. Now, the only way I know of getting rid of this log is to get rid of that log at the same time if I combine them, otherwise it's just going to be horribly messy. So therefore, I'm going to combine the logs first. Even though this might seem a bit weird because I'm just bringing more things around the y and seemingly making it more complicated. But I want to be able to get rid of the log. So now I can do both sides x to the power. They're inverse functions, so I get rid of them. So I've now got 2y minus 1 over 5 equals x squared. So times by 5, so 2y minus 1 equals 5x squared, plus 1, so 2y equals 5x squared plus 1, and then divide both sides by 2. There we go. That's the answer. Let's have a look at the next question. There's a few ways of doing this. Do you know what I'm going to do? I'm going to do it two different ways. The first way is I'm going to sling this over to the right hand side so that log x equals 10 to the 7 minus log y. And then I'm just going to do 10 to the power of both sides. And they cancel because they're inverse functions, so x equals 10 to the 7 minus log y. I feel like that's technically correct, but that bugs me a bit because I feel like we can make this look better. I'm instead going to try a different method where I combine the logs. So I'm going to say that's log xy equals 10 to the x, 10 to the 7, sorry, and then I'm going to do 10 to both sides, which means that cancels. So then I can just write x equals 10 to the 10 to the 7, which is a pretty horrible number, but whatever, we're stuck with it, divided by y. I kind of prefer that answer. And I guess you could also have rearranged that to get to that one as well. Let's have a look at the next question. Well, there's a trick here, which is that we do log to both sides. Why on earth would we do this? I'm not going to bother with that bracket. The answer is that we can now bring down the power. So we've now got x log 7 equals x plus 1. Now we do need the brackets to indicate that it's multiplying the whole thing, log 2. Now we can multiply it out, so x log 7 equals x log 2 plus log 2. I'm going to sling this over the other side and factorise at the same time. Let's just save a bit of time here. So that's log 7 minus log 2 equals log 2, which then means that x equals log 2 divided by log 7 minus log 2. There we go, that's the final answer. Last question. So this question is saying make x the subject and write it in terms of a. So we're going to have to get rid of b. Okay. This is a pretty grim question. I'm actually recording this for the second time because I made a bit of a mess with it the first time. So I can write here, I can use y equals y to write a to the x equals 4b to the x. It said in terms of a. I'm just going to immediately get rid of b, which means I can write a to the x equals 4, and then b is just 2 over a to the x. Now it gets a bit messy. I'm not necessarily going to keep saying out loud what I'm doing. There we go. I can multiply both sides by a to the x. And that's just a to the 2x on the left hand side. I can now do log to base 2 of both sides. Why would I do that? I'm doing that for a specific reason, because I can see it's going to really help on the right hand side. Now, I can use my log rules on both sides. I'll continue up here. On the left hand side, I can use it to bring down the 2x, which is the power. And on the right hand side, I can use it to split this into 2. And I'm just going to put that x in front. Now notice, log to base 2 of 4 is 2, log to base 2 of 2 is 1. So now let's just immediately rewrite that with that extra kind of tidiness because of the amount of cancelling using log to base 2 enabled us to do. That's simply 2 plus x. I'm now going to bring the x over to the other side and factorise. Let's do that at the same time. 2 log to base 2 of a minus 1 equals 2. And then I'm going to divide both sides by that bracket that's on the left hand side so that I can get x equals, and this is mission accomplished. 2 log to base 2 of a minus 1 is what's on the bottom. There we go. Hopefully you found those examples useful. Thanks for watching.